Every legendary maker, engineer, and electronics hobbyist started with this exact circuit. If you haven't built a 555 timer LED flasher yet, you're missing out on the official Hello World of hardware. Today, we're building the classic, and I'm going to show you how it works so you can start designing your own circuits. Stay tuned to the second part of this video, where I'll explain how this circuit works. I've packed my favorite 555 timer projects into a free ebook. Yep, totally free. Don't miss it. Click the link in the description to get yours. Here are all the components you need to set up this circuit. 4 jumper wires, 1 47 kilo ohm resistor, 1 10 kilo ohm resistor, 1 330 ohm resistor, 1 10 microfarad capacitor, 1 red LED, 1 555 timer IC, a 9-volt battery buckle connector, a 9-volt battery, a breadboard to connect everything together. The 555 timer IC comes with 8 pins. There is a notch or a dot on the chip's body. Pin 1, located at the top left, serves as the ground or ground supply. Pin 2, the trigger pin, initiates the timing interval in monostable and astable modes. Pin 3 serves as the output, providing the timer's operational result depending on its mode: monostable, astable, or bistable. Pin 4, the reset pin, is used to reset the 555 timer's internal flip-flop. Pin 5 serves as the control pin, enabling you to adjust the threshold voltage levels used by the internal comparators to set and reset the flip-flop. Pin 6, the threshold pin, monitors the voltage of the capacitor in the circuit. Pin 7, the discharge pin, manages the timing capacitor's charge and discharge cycle. Pin 8, known as VCC, supplies power to the IC. Let's set up the circuit step by step. Begin by positioning the 555 timer on the breadboard. The pins are numbered counterclockwise, starting from the top left corner. Refer to the later circuit diagram if you have questions about the circuit connections. Insert the 555 timer in the middle of the breadboard. A jumper wire connects pin 1, or ground, to the negative rail. A jumper wire connects pin 8, or VCC, to the positive rail. Use a jumper wire to connect pin 2, or trigger, to pin 6, or threshold. Use a jumper wire to connect pin 4, or reset to pin 8, or VCC. Bend the ends of a 47 kilo ohm resistor. Insert a 47 kilo ohm resistor to pin 2, or trigger, and pin 7, or discharge. Bend the ends of a 10 kilo ohm resistor. Insert a 10 kilo ohm resistor to pin 7, or discharge in pin 8, or VCC. Insert a 10 microfarad capacitor into pin 2, or trigger, and the negative rail. The anode is in pin 2. Bend the ends of a 330 ohm resistor. Insert a 330 ohm resistor to pin 3, or output, and a few rows below the 555. Insert a red LED into the same row as the resistor and the negative rail. The cathode is in the negative rail. It's time to connect the power supply. Insert the positive lead to the positive rail. Insert the negative lead to the negative rail. We have successfully completed the circuit. You can easily adjust how fast the LED blinks by changing the capacitor. Think of the capacitor like a tiny battery. A larger 100 microfarad capacitor takes longer to charge and discharge, resulting in a slow blink. A smaller 1 microfarad capacitor cycles quickly, making the LED blink fast. Let's dive into the circuit and break it down step by step. This diagram shows a classic astable multivibrator circuit built around a 555 timer integrated circuit, designed to continuously flash an LED. In an astable configuration, the circuit has no stable state and automatically oscillates back and forth between high and low voltage levels. The timing of this flashing cycle is entirely dictated by how fast an external capacitor charges and discharges through a network of resistors. The entire circuit is powered by a 9-volt battery connected to pin 8 and pin 1. Pin 4 is tied directly to the positive supply line to prevent any accidental resets from interrupting the cycle, while pin 5 is left disconnected as a standard practice when external voltage control isn't required. The heart of the oscillation process relies on the continuous charging and discharging of the 10 microfarad capacitor. When power is first applied, the capacitor is completely uncharged, meaning the voltage across it is 0 volt. Because pin 2 monitors this voltage and senses that it is below 1/3 of the supply voltage, it forces pin 3 to go high. At the same moment, pin 7 opens up, allowing current to flow from the 9-volt supply through the 10 kiloohm and 47 kiloohm resistors to charge the 10 microfarad capacitor. The time it takes for the capacitor to charge up is determined by the combined resistance of both components. 10 kiloohm plus 47 kiloohm equals 57 kiloohm, keeping the output high during this window. Once the capacitor charges up and its voltage hits 2/3 of the supply voltage, pin 6 triggers an internal flip-flop inside the 555 timer. This instantly switches pin 3 from high to low. Simultaneously, pin 7 is internally connected to the ground, creating a brand new path for the stored energy. The capacitor now begins to discharge its stored current back down through only the 47 kiloohm resistor directly into pin 7. Because the current bypasses the 10 kiloohm resistor during this phase, the discharge time is slightly shorter than the charge time. As the capacitor empties out and its voltage drops back down to the critical 1/3 VCC mark, pin 2 senses the drop and snaps the internal flip-flop back to its original state. The output at pin 3 goes high again, the discharge path at pin 7 closes, and the capacitor starts charging all over again. This endless loop creates a continuous square wave at pin 3. When pin 3 is high, current flows through the 330 ohm current limiting resistor and illuminates the LED. When pin 3 drops to ground, the LED turns off. The 330 ohm resistor is essential here to safeguard the LED from burning out by keeping the forward current within a safe operating range. I hope this video has shown you how to make the classic LED flasher with a 555 timer. Want to dive deeper into 555 timer projects? Grab my free ebook packed with awesome circuits and ideas. Just click the link in the description to download your copy now. If you found this video helpful, give it a thumbs up, consider subscribing for more electronics tips and tutorials, and hit the bell icon to never miss an update. Thanks for watching, and I'll see you in the next video.